Hello, welcome back to another live stream with Kiwi Co unboxing. I am making a glowing pendulum.
You guys?
Yeah.
You want to explain what a glowing pendulum is?
I'm not exactly sure what it is.
Well,
But it does.
He's messing with ultraviolet light, so.
Yeah, I know that much because I looked in here and it's ultraviolet light and it's.
Some people say that things aren't rocket science. This is definitely rocket science. They give you blueprints.
Yeah, this is there's A, B, and C. Those are all different parts to making this. Basically, these are my blueprints. Here, I'm making like the place where it's swinging around. Right here, I'm making the actual pendulum. And here, I'm attaching them together. And then on the back, there's like extra stuff. So basically, it's gonna hopefully look like this, and just swing around. And I'm tired. Why? I don't know. Okay, so I'm gonna start. Ashley's gonna be reading this and explaining the science behind it.
In this issue, the butterfly effect. This is not at all related to.
And it ends up being related.
No,
I read those before.
no, it doesn't.
Step 1, unfold the globe board and stick the white soft dots to flap A and flap B.
The white soft dots.
Okay,
So the butterfly effect. Can a butterfly flapping its wings cause a tornado in Texas? But the idea behind this question is very important for scientists who study the chaos theory that makes your glowing pendulum move the way it does. You see, tornadoes are actually pretty picky when they're forming. There are lots of factors that go into making a tornado. And they all need to be balanced just right for the tornado to form at all. A slight stronger gust of wind could be the deciding factor between tornadoes spinning up and a normal cloudy day.
I don't think that's true.
What?
There is cold air in the sky, and there's warm air on the ground, and they're blowing in opposite directions. That forms a tornado. It's not just like one big gust of wind going in one direction. That's not how a tornado works.
I guess.
Tornadoes start by two different temperature winds going in opposite directions.
I know, but if the wind is wrong, then it would be wrong.
Okay, step 3. Okay. Fold flap A up and then over the area, then over to area A. Press to connect the soft dots to the matching scratchy dots.
Scratchy dots.
I'm very confused again.
The scratchy dots are Velcro, by the way.
How does this fit in?
Okay, sorry then.
There's B.
So could a butterfly cause a tornado? At least not without a lot of other things. But because the tornadoes are so picky, even all the way from the Amazon might be the final factor that's needed with chaotic things like tornadoes. There's just no way to know for sure. Okay.
Okay, so now this is stance. So
that's good because then you can stick a light through it.
boom. So step 1, fit the battery pack into the cradle of the LED holder. Make sure the wire is put. What? Confusion is me.
I'm back, and I have a question for you guys to comment down below.
No one's watching.
Well, we'll watch later, hopefully.
Okay.
Because the butterfly population is like not great. It's not that big. When all the butterflies are gone, does that mean tornadoes will stop completely? Or does it mean that
they'll be more frequent?
Yeah, they'll be more frequent because butterflies might change the tornadoes if it's that exact. So like if they flap their wings at the wrong time, then it could be wrong.
Did you go like this and flap?
I did.
So the things are right like this. Okay, like this. And then I take UV LED. This thing, I think.
One morning in 1961, a meteorology professor at MIT named Edward Lorenz was running some weather tests on a computer. Meteorologists are scientists who study weather, so this was pretty normal for him. When Lorenz fed some weather conditions into a computer program, like such and such temperatures and so humidity, his computer would make a graph and told him how the weather would turn out. The computer had made a graph that was wildly different from his other tests, but it wasn't a random mix-up at the beginning. The graph looked the same, but yeah, by about halfway it was going up where the others went down. It was bumpy when the others were flat. It was clear that something was wrong. And then Lawrence looked at the numbers. He plugged in.
Okay, that's
Oh, that is easy. But yeah.
Oh, cool.
Whoa!
Look.
Does that go away eventually?
Yeah. So look.
That's so cool. Write your name.
I can't like that.
What the heck is that?
Wait, no.
Oh, that's dog hair.
For sure.
What do you have? There are like little dots too. I think it's just dust, but in his other tests he used numbers 0.50617 I mean. In the morning test he used 0.506. He rounded the numbers because of those extra decimal places didn't seem too important, and he wanted to go get his coffee. It was like talking at a couple of raindrops
I'm on like the
of
last
a thunderstorm.
I'm on part C.
2 missing raindrops and had turned would be a thunderstorm into a drizzle. The shocking result of results led Lorentz to come up with the chaos theory, one of the most important scientific ideas in the 20th century. The basic idea was that some things like weather don't follow the simple, easy to approximate patterns. The rules they follow are very, very complex. That makes them extremely sensitive in their starting conditions, so that even the tiniest change when rounding up thousands of decimals will have a huge complex effect. Lorentz's discovery opened up a new way to investigate the world. Scientists realized that lots of things they used to think were completely random, like the irregular heartbeat in a person's heart with heart problems, or how turbulence happens around the airplane wing, are actually chaotic. They're really complex, sometimes too complex to always predict. But they have patterns that can be understood. Thanks to the chaos theory and Lorentz's cup of coffee, we can make a better sense of our complicated world. Alright, so that's the chaos theory pretty much. Long story short, it's like saying if you do origami and you get one fold a tiny bit wrong, it won't come out right. It'll come out imperfect or something. So if you change one little thing, it'll change everything else. So that's the chaos theory. Light out of darkness. Why does the ultraviolet when someone's playing with an ultraviolet light, it's a black light. Shine an ultraviolet light on your glow board, and something unusual happens. It starts glowing. No, not in my eye.
Oh yeah, earwax is earwax glows.
Earwax glows.
Actually, they gave me a bag of citric acid because I'll need it. I use for food consumption.
Dang it! So what are you doing right now? Are you
I'm screwing the thing that makes it spin in. This. So now it's weighted on the back.
That's kind of nuts the other day.
Chaos. That's really
Does it ever stop?
No. Apparently it does.
Rika, come on.
Read the one. Yes.
There's no motor on it.
No.
If you put a motor on it, that'd be cool.
That's so cool. That's amazing.
Yeah.
What kind of paper is that? What is that?
It's like, it feels like sandpaper.
Well, I mean, what
What
is
happens if I rub it? Oh, no, put the black light on where I rub it. Or actually,
This is a pretty cool kit.
The black light on my...
So show us So there's no way of judging where it's going to go?
No, that's chaos theory.
See, I think the chaos theory is that there is a mathematical formula that can explain where it's going to go. Right?
I think it's beautiful.
It was amazing.
Looks like a pretty.
Does it do different colors or just green?
That's
Just
pretty.
green.
Oh, it's like a heart.
Okay, I hear lots and lots of movement.
Yes, it's all like weird and.
That's wild looking.
Yes, it is. Do it again.
I like when it wraps
It
around
never
the
does
top.
the same one twice. No.
Well, I doubt that. If you do it enough, it'll do the same one twice.
Right.
Yeah,
That's
I mean, if you do it enough times.
that's chaos theory.
It's all chaos.
Right? Closed loops.
It would never do it the same one twice if the hinges were always.
If the hinges were
Well,
stiff, it would
yeah.
always do the same one twice.
No, if the hinges hinges were I don't know how to say it.
If the hinges were motorized and stiff, it would be the same thing all the time. But because there's an infinite amount of variations of their movement.
Right, yeah. Alright, so
This was at what?
Alright, so
I have one more LED. I can unplug that LED and plug in this one.
So for now, that we're gonna do the next Kiwi Co
Hey.
thing sometime soon. So for now, flip up again.
Ow!